Ever get that feeling when, everyone around you seems to be fluent in some new industry language and you're still figuring out the basics?
Happens all the time.
Yeah, and for many in the built environment, building information modeling, or BIM, can feel exactly like that. You've heard the term tossed around, but what's really going on behind the buzz?
That's a great question, and that's exactly what we're trying to unpack today.
Mm,
You really need to forget thinking of BIM as just, another bit of software you have to buy.
right.
Our aim here is to really get into it as a fundamental change in how we approach construction projects, from that very first idea right through to actually managing the finished building.
So consider this your kind of shortcut to understanding what BIM truly means and why it's become so critical, really, no matter what your specific role is or how techie you feel you are.
Precisely. It's for everyone involved.
Yeah, absolutely. So we've looked at a whole range of material to bring you the core of BIM, digging into everything from the practical first steps to the bigger strategic picture. Okay, let's get stuck in. What exactly is BIM beyond all the hype?
Well, the first thought for a lot of people is that BIM is just, fancy 3D CAD or maybe one specific software package they've heard of.
Yeah, that's common.
And while technology is definitely part of it, the real core of BIM is a process. It's a better way of working together and communicating throughout a building's whole life. And really, at its heart, it's driven by people collaborating more effectively.
Right. So it's less about the tool itself and more how you use it together.
Yeah.
Like moving from just drawing lines to making really smart models. I mean, a wall in BIM isn't just a couple of lines on a screen, is it?
Exactly. It completely transforms. That wall becomes a component. It's loaded with information, its performance characteristics, how it gets installed, even, how you maintain it down the line.
Hmm.
The essence of BIM is really this connection. The building's entire journey, that's the building part, is linked intrinsically with all the data it contains, the information in its 3D shape, its geometry, the modeling.
Okay.
And all of that is supported by, well, the new processes we need to adopt, the people involved, the teams, and the digital platforms that help bring it all together.
Okay. So it's a much bigger idea than just the specific software you happen to be using.
Mhm.
But what's actually driving this big shift? I mean, why all the fuss? What are the real advantages of using BIM?
Well, the push towards BIM, it's coming from some pretty fundamental needs in the industry. First, there's a growing recognition that we just have to go digital, moving away from all the traditional paper-based stuff.
Makes sense? Less paper, fewer errors, maybe?
Hopefully. And second, we need the right foundation in place. We need efficient ways to communicate, to share information seamlessly, and to transfer data reliably. Without that groundwork, the more advanced parts of BIM, they just can't really take root.
Yeah, you can't build a digital skyscraper on, shaky foundations. That makes total sense. But what about the practical side? Implementing BIM must involve some, serious investment, right? Upfront costs.
Oh, it does, absolutely. And that's precisely why having a strong business case is so critical. Organizations, they need to be able to justify the costs, not just the new technology, but also the upheaval, the changes in how teams are structured and how they work.
Right, the disruption factor.
Exactly. And showing a clear return on that investment, ideally a relatively quick one, well, that's a key consideration for anyone making these kinds of decisions. You have to prove it's worth it.
So what are those actual returns then? What are the real-world benefits BIM brings to a project? Can you give us some examples?
Yeah, definitely. Benefits are pretty substantial now, and they're increasingly well proven. For instance, BIM gives you much greater certainty over the project program, how things will progress, and it helps identify potential problems much, much earlier in the process.
Okay, so spotting clashes or issues digitally before they happen on site.
Precisely. And that proactive approach, well, it can save significant time and money down the road. You're fixing problems on a screen, not with a jackhammer.
Sounds much better. What else does it offer?
Improved health and safety is another really critical advantage. By visualizing the project in detail right from the start, and crucially, getting input from everyone involved.
Like the site teams.
Yeah, exactly. You can spot and address safety risks, things associated with particularly dangerous activities, well before anyone even steps onto the site. And BIM's influence, it isn't just confined to the design office, it really impacts the actual construction sequence and how things are delivered.
Interesting. So it's not just about making the plans look good, but also about ensuring a safer build process.
Exactly right. Furthermore, BIM supports looking at infrastructure projects across their entire life cycle. So from the initial design and construction all the way through to the ongoing operation and maintenance.
Right. Cradle to grave. Or cradle to cradle, perhaps.
Yeah. A really significant example in Europe is the Crossrail project in London. Massive underground rail project. They've used really innovative BIM methods for everything, from the complex tunnel engineering to the station designs. And there's been a very strong focus on managing all that data for the long-term operation of the railway itself.
Wow, yeah, that's a project on a huge scale. Does BIM have a role to play in even broader contexts, like, say, planning for entire cities?
Oh, absolutely. That's where integrating geographic information systems, or GIS, becomes really crucial. Think about it. Most construction projects, they start with data about the site, the surrounding land,
Topography, utilities,
and
boundaries.
all of that. BIM can incorporate this GIS data so you can visualize mapping and location-based information right within the project model. This is incredibly powerful for citywide initiatives. It allows you to analyze the potential impact of projects on things like traffic flow, population density, maybe even economic trends.
Mhm.
You could even, imagine applying this on a national or even international scale eventually.
That's a perspective I hadn't really thought about BIM beyond the individual building. What about other design disciplines, like landscape architecture? Is BIM relevant there, too?
Definitely. Landscape architecture is another area where BIM is, well, really starting to gain traction. Historically, it hasn't always had its own dedicated software and platforms in the same way as architecture or engineering.
Right.
But landscape design, it involves much more than just, picking plants. It includes detailed site modeling, shaping the
Mhm.
terrain, considering the overall aesthetic and how the whole scheme will function.
Water management, earthworks.
Exactly. For large infrastructure projects, things like forestry, managing wildlife habitats, complex water management, these can be enormous undertakings. And BIM provides the tools for much better coordination between the landscape team and the wider construction team.
It's really fascinating to see how broadly applicable these principles of information modeling actually are.
Yeah.
Speaking of other applications, can we learn anything from other industries?
Yeah.
Have they adopted similar approaches?
Oh, definitely. This whole idea of information modeling and managing knowledge across complex projects, it isn't unique to construction at all. The automotive industry, for example, has benefited hugely from international design and safety standards and the widespread use of pretty standardized CAD platforms.
Makes sense. Fewer compatibility issues.
Precisely. And a key lesson from them is the absolutely vital role of the client's commitment, demanding new technologies that support the entire supply chain and ensuring that information can be easily shared between different systems. Interoperability is key.
Right. If everyone's speaking the same digital language, things are just bound to run more smoothly.
That's the idea. And this concept of an information model that continues to evolve and is used for project management, that isn't new either. It's often called product lifecycle management, or PLM, in manufacturing.
Okay, PLM.
Yeah. And you'll also frequently hear the term integrated project delivery, or IPD, mentioned alongside BIM BODA, which maybe we can explore in more detail another time, is quite similar in principle to PLM. And when you get BIM and IPD processes working hand in hand, they can be incredibly effective.
Okay, so the model isn't just like a static set of blueprints then. It actually changes and develops as the project moves along. How does that work in practice? From the initial design idea to, say, the final operation of the building?
Yeah, the BIM model goes through quite a transformation as the project progresses through its different stages. This is often described using terms like the level of development or level of definition, LOD for short.
LOD, right. Heard that one.
It starts out as more of a design intent model, showing the initial concepts, the basic massing and layout. Then it gradually becomes a much more detailed virtual construction model that the contractors can actually use on site for, instructions, specifications, quantities.
So it gets richer with information over time.
Exactly. Think of it like a traditional blueprint evolving from a very rough sketch to highly detailed engineering drawings. The BIM model follows a similar path, with increasing levels of detail and, crucially, information being added as the project moves towards construction and handover.
And it's absolutely critical to keep that model current.
Right.
It can't just be something that gets updated, sporadically or right at the very end.
Oh, absolutely not. Because construction projects, they can take a significant amount of time, years sometimes.
For sure.
The model needs to be a consistently accurate and up-to-date source of truth. That's where continuous model management comes in. Someone, or often a dedicated role, needs to be responsible for making sure the model always reflects the latest decisions, the latest site information throughout the project's life cycle.
Okay, so it's like a living document, or rather a living digital representation of the project. Now, you mentioned earlier that we often don't have just one single massive model, but maybe different models coming together.
That's right, yeah. It's often more practical, especially on complex projects. Imagine it as a federated model, basically, a collection of separate, distinct models.
Okay.
Each one is typically created by a different specialist. The architect has their model, the structural engineer has theirs, the MEP, mechanical, electrical, plumbing consultants have theirs.
Right, their own domains.
Exactly. These individual models are then brought together, they're coordinated and combined to create a comprehensive view of the entire building. While maybe the ultimate aim is a single, fully integrated model one day, for now, this federated approach is much more common in practice.
So it's a bit like having the different consultants' traditional drawings, but in 3D model form, and then coordinating them into one master set of information.
That's a really good analogy, yeah. Similar principle, but much more powerful because the information is embedded.
And where does all this information, these different models, actually get stored and managed? It sounds like it could get incredibly complicated very quickly.
It could. And that's precisely where the Common Data Environment, or CDE, comes into play. The CDE is essentially the central online hub. It's the designated space where all project information, doesn't matter who created it or where it came from, is stored, managed, updated, and shared.
The single source of truth.
That's the term you always hear, and it's accurate. Think of it as the single source of truth for the entire project. It's like a constantly updated project brain that drastically reduces confusion, mistakes, people working off old info.
Yeah, I can see the value there.
And while the information is shared and everyone can access what they need, the original creator still typically owns their information and controls who can actually make changes. This does require a much more organized approach to managing data, though clear rules for naming files, identifying their status, their source, it needs discipline.
Okay, so what are the specific advantages then of having this CDE? It sounds like maybe a bit of effort to set up initially.
The benefits are really numerous,
Yeah.
and they definitely outweigh the initial setup effort in the long run. A CDE provides strict version control, so you know everyone is working with the latest information. That alone reduces the risk of costly errors from outdated plans massively.
Yeah.
It makes it incredibly easy to distribute information to the entire project team, subcontractors, everyone,
Yeah.
because all the disciplines are working from the same coordinated, up-to-date information source. Coordination itself is significantly improved. Fewer clashes, fewer surprises.
Right.
Plus, the information in the CDE isn't just for design and construction. It can be reused for later activities like construction planning, cost estimation, risk assessment, and critically, for managing the building after it's handed over facilities management.
Ah, the whole life cycle again.
Exactly. Data is stored securely, usually on remote servers with controlled access. Previous versions can be archived digitally, which gets rid of bulky physical storage. You also see a big reduction in the need for couriers and postal services, saving time and money. And maybe most importantly, teams that are spread out geographically can collaborate much more effectively.
That's a really compelling list of advantages. It makes the case pretty strongly.
Mm.
Now, you also mentioned something earlier about plain language questions.
Yeah.
What are those and how do they relate to the model's development?
Yes. Plain language questions, or PLQs. They're exactly what they sound like. Clear, simple questions that the client or the employer asks the project team at key decision points during a project or an asset's life cycle.
To help them make decisions.
Precisely. They're designed to inform the client's decision-making. And the key point is that the level of detail and the specific information required in the BIM model at any given point should be driven by the need to answer these specific PLQs effectively.
Okay, so you don't model things just for the sake of it.
Exactly. Providing way too much detail too early can be incredibly wasteful time, effort, file size. But providing too little information means you can't actually answer those crucial questions the client needs answering to move forward. It's about finding the right balance, driven by the decisions that need to be made.
Okay, that makes a lot of sense, providing the right information at the right time,
Yeah.
based on what the client actually needs to know. Now, let's say someone's listening and thinking, okay, this BIM thing sounds important, sounds beneficial, but where on earth do we even start? What are some key steps for actually beginning with BIM and trying to encourage that collaboration you mentioned?
Yeah, that's the million-dollar question for many. The first, absolutely vital step is to recognize that BIM requires buy-in from everyone, really everyone involved, from the client and the designers right through to the contractors, the subcontractors, and even the eventual end users of building.
It's a team sport.
It absolutely is. It's not just about the technology. Investing in people and their skills is just as crucial, maybe even more so. A good rule of thumb people sometimes use is to aim to spend a similar amount on training, professional development, and just time for people to practice and upskill, as you do on the actual BIM software and hardware itself.
Wow, that's a significant investment in people. So it's not just buying the shiny tools, but really teaching everyone how to use them effectively and, crucially, how to work together in this new way.
Precisely. BIM isn't simply about picking out some software tools off a shelf. It's about establishing a really strong framework for working collaboratively. This includes defining a shared methodology, a common approach for managing all that construction information within the CDE, ensuring everyone can access the right data securely.
And procurement comes into it too.
Hugely. The way you choose to procure a project, the contract model, makes a big difference. More collaborative contract models, things like NEC or integrated project delivery, they tend to lead to much better BIM outcomes because they encourage that shared approach.
Right, aligns incentives.
Exactly. And you need to think about the contracts themselves, clearly defining what BIM deliverables are actually expected, how data will be exchanged between parties, considering things like insurance implications for digital data, and also thinking about soft landings.
Soft landings, what's that?
It's basically about involving the design and construction teams more during the handover phase, and even post-handover, working with the building's users and operators. It ensures a smoother transition and helps make sure the building actually performs as designed and meets the real-world needs of the people who will use the space every day. It connects the design intent to operational reality.
That sounds like a much more joined up, comprehensive approach than just, installing some new programs and hoping for the best. What about the actual digital tools themselves? How do you go about choosing the right ones? It seems like there are so many options.
There are, and when you're selecting digital equipment, the ability of different systems to talk to each other, interoperability, is absolutely key. It's rare that a building can be designed and constructed using software from just one single company.
Yeah, different specialists use different tools.
Exactly. So the tools you choose, they need to be compatible with each other, not just technically, but also at a workflow level, especially when you're working in multidisciplinary teams. It's also worth seeing if there are any free tools or resources available, especially when you're just starting out, to help you get your feet wet.
Good tip.
And really importantly, always have an exit strategy. Have a backup plan. What happens if a software company goes bust or stops supporting a particular program you rely on? You need to have thought about how you could move to another provider if necessary without losing all your data or grinding to a halt.
Those are really practical, important points to consider. You mentioned earlier the project information model, or PM, and the asset information model, or AIM. Can you just clarify the difference again and when each one is used?
Sure. So during the design and construction phases, the project delivery phase, the team develops the project information model, the PM. It starts out focused on design intent, as we said, and it progressively evolves into that virtual construction model.
Okay, the PM is for getting it built.
Right. Then, once the project is handed over to the client or operator, the responsibility for the information transfers. The PM then evolves into, or informs the creation of, the asset information model, the A, and the AIM is used for the ongoing operation and maintenance of the building or infrastructure throughout its life.
Got it. PM for delivery, AIM for operation.
Exactly. And the information manager role is really crucial here, acting as the conduit for delivering structured information to the client through agreed-upon information exchanges at key decision points in the project.
So the PM builds up, gets handed over, and becomes the basis for the AIM. Makes sense. Now, to make all of this run smoothly across the industry, there must be some established standards and guidelines, right? It can't be a free-for-all.
Oh, absolutely not. BIM standards are essential. They're there for creating, using, and maintaining all this information effectively and consistently. They promote best practices and help the industry achieve real, measurable improvements. Just sharing construction info drawings, specs, schedules in a consistent way leads to significant cost savings and much less waste.
Standardization helps everyone.
It does.
And what about ensuring that all these different software systems from different vendors can actually talk to each other? You mentioned interoperability.
Yeah, that's where concepts like Open BIM and specific standards like Industry Foundation Classes or IFC come in. Open BIM is really an initiative, a movement promoting the ability of different software to work together based on open, neutral standards, not locked into one vendor.
They're neutral.
Exactly. And IFC is a specific, internationally recognized open standard file format. It allows model data geometry and information to be exchanged between different software platforms without losing critical information or at least minimizing loss. Most modern BIM software supports importing and exporting IFC files now. There's even an organization, Building Smart, that provides certifications for applications that meet consistent IFC standards. This ability to exchange information reliably between different software, whether it's for initial design or later uses like facility management software or structural analysis tools, it's absolutely fundamental for true collaboration.
So IFC is like a universal translator for BIM data.
That's a great way to put it. It allows different consultants, different suppliers to work together on open BIM projects using their preferred tools without being forced to buy the same software as everyone else. Ideally, all projects would be open in this way, ensuring no one is excluded based purely on their software choices.
You also mentioned some specific standards and guidance documents earlier. Could you touch on those again briefly?
Sure. In the UK, there was PAS 11922. PAS stands for Publicly Available Specification. This one specifically focused on how information is managed during the delivery, the construction phase, of projects using BIM. It provided a kind of code of practice for the industry.
Okay, PAS 11922 for delivery.
Then there was PAS 11923, which addressed the operational phase. It specified how information should be transferred from that PIM we talked about to the AIM, and also how you might create an AIM for existing buildings that maybe weren't designed using BIM originally.
Right, for retrofitting the information.
Exactly. And then there's COBE. That stands for Construction Operations Building Information Exchange. It was originally developed in the US, actually. COBE focuses more on the information itself rather than the complex 3D geometry. It provides a standardized way to organize, document, and share asset information, things like serial numbers, warranty dates, maintenance schedules, in a relatively simple format, often described as being transferable via a basic spreadsheet.
So it's really practical for the facilities managers.
Hugely useful for facility managers and building owners, yeah. It makes that handover of crucial operational data much more structured and usable.
These all sound like really important frameworks. Were there any big government initiatives that helped push the adoption of BIM, particularly in the UK where some of these standards originated?
Yes, definitely. In the UK, the government published its Construction 2025 strategy back in, 2013, I think. It set out some really ambitious long-term goals for the construction sector, and BIM was seen as a key enabler for achieving them.
What kind of goals?
Things like significant reductions in both the initial construction costs and the whole life costs of buildings, faster project delivery times, much lower carbon emissions from construction and operation, and also an increase in exports of UK construction services and products.
Ambitious stuff.
Very. And the UK's early focus on BIM, particularly around PAS 1192, actually led to it forming the basis of a subsequent international standard, ISO 19650, so its impact has extended far beyond the UK now.
Interesting to see how government policy can really shape industry practices on that scale.
Yeah.
What about more specific industry guidelines, maybe from professional bodies?
Yeah, good point. The RIBA Plan of Work in the UK, which is a long-established framework outlining the stages of designing and constructing buildings, has been significantly updated over the years to reflect how BIM has changed the way project teams work and exchange information at each stage.
So adapting existing frameworks.
Exactly. And similarly, in the U.S., the American Institute of Architects, the AIA, they've developed a whole suite of dedicated contract documents specifically designed to address BIM and digital data use on projects. They provide frameworks and protocols for things like integrated project delivery, detailed information exchange requirements, how data is licensed, specific BIM exhibits to attach to contracts, protocol forms, and so on.
So it seems like there's a growing body of standards and guidance out there to help the industry navigate this whole new world of BIM. But as you said earlier, BIM isn't just about technology and standards and processes, is it? You really emphasize that it's also driven by people.
Absolutely, 100%. BIM is fundamentally a people-led process. It requires a combination of, yes, the technical expertise, the hard skills, but also, just as importantly, those crucial interpersonal skills. The soft skills like collaboration, communication, negotiation, problem solving, right across all parts of the industry. Some research even indicates how vital these soft skills are for national economies, not just construction.
That makes perfect sense. You can have the most advanced tech stack in the world, but if people can't or won't collaborate effectively, it just won't reach its full potential. How do you actually foster that kind of collaborative environment? Any tips?
Well, sometimes the sheer size of the team can play a role. There's a concept, you might have heard of it, called the two-pizza rule, popularized by Jeff Bezos at Amazon.
The two-pizza rule.
Yeah, the idea is that teams should ideally be small enough that 2 pizzas would be enough to fuel everyone for a meeting. The thinking is that larger teams can sometimes hinder effective communication and quick decision-making. Smaller teams often collaborate more naturally.
That's a very memorable way to think about team dynamics. But what about dealing with resistance? There must be people who are skeptical or hesitant about adopting BIM. How do you encourage those BIM cynics?
Yeah, that's a common challenge. Encouraging those who are hesitant about BIM, it requires a pretty thoughtful approach. You can't just force it on people. Sometimes highlighting the cost of not adopting BIM can be effective, pointing out missed efficiencies or potential risks.
The cost of doing nothing.
Exactly, as can clearly explaining the tangible advantages in their terms. For example, showing how BIM object properties make it much easier and faster to find specific information compared to trawling through hundreds of traditional drawings or documents, making it real for them.
Show, don't just tell.
Right. And it's also really important to respect their existing knowledge and experience, involve them in the transition process. Maybe you can adapt some familiar practices where possible, at least initially. You could even give them specific roles where they can share their valuable expertise rather than making them feel like their skills are suddenly becoming outdated or irrelevant.
So it's about demonstrating the value clearly, respecting their experience, and making them feel part of the change, not just subject to it. What are some of the other common obstacles or barriers when implementing BIM?
Well, often one of the main challenges is simply that shift in mindset we talked about, overcoming that inertia, the this is how we've always done it mentality. Fostering a genuine culture of sharing information and collaborating openly is absolutely essential, and sometimes that's harder than learning the software.
Culture change is hard.
It is. BIM is as much about changing processes and ingrained behaviors as it is about the technology itself. As the saying goes, to improve is to change. To be perfect is to change often. You have to embrace the change.
Change can definitely be difficult, no doubt about it. Now, for those organizations or teams looking to actually implement BIM more formally, what are some practical steps they should consider when developing their overall BIM strategy?
Okay, so developing a BIM strategy, it shouldn't happen in a vacuum. It should really be directly informed by or be a response to the client's employer's information requirements, the EIR. That document sets out what information the client needs, when, and why.
So the strategy serves the client's needs.
Fundamentally, yes. It's also important to remember that not all digital project data will necessarily be in a 3D model. A good strategy needs to consider how traditional documents, like reports or specifications, are linked into the overall information structure, and it needs to establish clear, unambiguous rules for things like classifying information and naming files consistently. Chaos helps no one.
Yeah, consistency is key.
And assessing the current skills and knowledge of your team is also crucial. Where are the gaps? What training is needed?
And then you need a specific plan to put that strategy into action on a project, right?
Exactly. The supplier or the project team typically responds to the client's EIR with a BIM execution plan, often called a BEP. The BEP outlines their proposed approach, their capabilities, and how they'll meet the client's information requirements using BIM. It details the how.
What goes into a BEP?
Key elements of a good BIM project strategy, which would be documented in the BEP, include clearly defining the specific goals for using BIM at each project stage, identifying the actual BIM deliverables, what models, what data extracts are required, agreeing on key workflows like how clash detection will be managed or if 4D construction simulations will be created,
Okay.
selecting the specific digital tool and software stack you'll use, ensuring you have the necessary IT infrastructure networks, servers, CDE platform, actually setting up and configuring that common data environment, agreeing on the formats for model outputs and data exchanges, like using IFC,
Right, the technical nuts and bolts.
defining shared coordinate systems so all the models line up, determining how data will be segregated or organized within the models, planning for the necessary human resources, who does what, and crucially, holding regular team meetings specifically to review the models and discuss coordination. The BEP brings all of this together into a kind of living document that guides the project's digital delivery.
Hmm. It sounds like there's certainly a lot to manage there, a lot of planning required up front. What are some of the potential pitfalls or maybe thorny issues that can arise with BIM implementation?
Well, having effective change management processes in place is absolutely critical for successful adoption, as we've discussed. Data security is another massive concern, especially with information being shared digitally in a CDE. Understanding and actively mitigating digital security risks is paramount.
Yeah, protecting that valuable data.
Definitely. Then there are the legal issues. Things particularly concerning liability. Who is responsible if there's an error in a model contributed by one party but relied upon by another? And who actually owns the information in these federated models? These need careful consideration, often in the contracts. There's even the potential for new types of disagreements or disputes to emerge, specifically related to BIM data.
Hmm. Any solutions there?
Well, approaches like integrated project delivery, IPD, where the client, designer, and contractor essentially form a more integrated team and share the risks and rewards of the project more explicitly, can be one way to address some of these liability concerns by fostering a less adversarial environment.
Interesting. Shared risk, shared reward.
Right. It's also just important to recognize that some parts of the industry, maybe those whose traditional business models rely on information asymmetry or exploiting inefficiencies, might resist BIM simply because its transparency and potential efficiencies could be seen as a threat.
So while BIM offers really significant advantages, it's definitely important to be aware of these challenges. Change management, security, legal aspects, potential resistance, and address them proactively. What about the bottom line, the economic impact? Does BIM genuinely lead to cost savings in the long term?
It's often said that BIM-related cost savings are typically realized as part of a broader program of change. It's not usually just BIM in isolation. It often goes hand in hand with adopting new ways of procuring projects like IPD and implementing those soft landings we mentioned to improve operational performance.
So it's part of a package deal for improvement.
Largely, yes. While BIM isn't some magic bullet that guarantees every project comes in under budget, it significantly improves how teams collaborate and, crucially, the quality and accessibility of information. This leads to better informed decisions throughout the project, which generally results in more predictable outcomes and reduced risk.
And spotting errors early.
That's a huge factor. Detecting and fixing mistakes or clashes early in the digital model, before construction even begins, is a massive source of cost savings compared to fixing them physically on site. Furthermore, the benefits of BIM extend well into the operational things of a building. It plays a vital role in how the asset is managed and maintained over its decades-long life, helping to optimize those whole life costs.
Right, thinking long term.
And there are other potential efficiency gains, too. Initiatives like the AutoCodes project, which aim to automate parts of the process of checking building designs against building codes using BIM data, show the potential for further savings through automation.
It's clear that BIM has the potential for some really significant economic benefits, not just during construction, but throughout the entire life cycle of a built asset.
Looking ahead now, what does the future hold for BIM? What are some of the emerging trends and innovations that you see? Well, the industry is definitely not standing still. We're seeing a steady move towards BIM becoming, well, just the standard way of working. It's moving from being a disruptive technology to more of a sustaining one in many areas. Looking forward, things like augmented reality, AR, and virtual reality, VR, are showing great potential for visualizing BIM data in really new and intuitive ways. Imagine walking through a virtual model on site using AR glasses.
Very cool.
However, all this greater connectivity also brings increased risks to data security. The need for buildings that are digitally secure, protecting both the building systems and the data they generate, is becoming increasingly important.
Cybersecurity for buildings.
Essentially, yes. And the sheer amount of big data that's starting to come from sensors embedded in buildings, tracking energy use, occupancy, environmental conditions, will require new methods and tools for analysis. That's where artificial intelligence, AI, and business intelligence, BI tools, will increasingly be used to analyze all this BIM and sensor data to find patterns and drive greater efficiency.
And the Internet of Things.
Absolutely. The Internet of Things, or IoT, has huge potential to connect various building systems together. HVAC, lighting, security, allowing them to communicate and be controlled intelligently, transforming user experience and operational efficiency. We're really only scratching the surface there.
It really sounds like we're just seeing the beginning of what's possible with this digital transformation. For people listening who want to learn more and connect with others who are active in the BIM space, where can they go?
Oh, there's a vibrant online community, utilizing online forums, social media platforms, particularly Twitter, using hashtags like hashtag BIMTwitter50 or hashtag Global BIM Crew can be incredibly valuable. Following industry blogs like Construction Code and others is also a great way to stay updated and learn from peers.
So tap into the community.
Definitely. There are also virtual BIM libraries online where you can download pre-configured digital objects like specific windows or doors or pieces of equipment. These can save time, although it's always important to check the quality and be mindful if they're tied to a specific manufacturer's product.
Good point about quality control.
And finally, just reinforcing that point about the level of detail understanding, the appropriate level of geometric detail needed in BIM models at each project stage is crucial. It's not always about making it look photorealistic. It's about having the right geometry and, more importantly, the right information needed to support decision making at that specific point in time. Avoid unnecessary complexity.
Focus on the information value. That seems to be a recurring theme. This has been an incredibly insightful deep dive into the complex but fascinating world of BIM. To try and summarize, what would be your single key takeaway for our listeners?
I think the core message really is that BIM is fundamentally about improving how we manage information and how we collaborate throughout the entire life cycle of a built asset from cradle to grave or even cradle to cradle. It offers really significant proven advantages in terms of efficiency, safety, cost predictability, and sustainability. It's guiding us towards a much more digital, integrated, and hopefully better future for the built environment.
A powerful summary. And finally, maybe a thought-provoking question for you, our listener, to mull over. With this increasing digitalization of the built environment that we've talked about, embracing concepts like smart cities, the Internet of Things, AI analyzing building data, how will this fundamentally change not only how we design and construct our buildings and infrastructure, but also how we actually interact with the spaces we inhabit day to day and the very processes that bring them into being?
That's a big one.
It is. It's a really fascinating evolution, I think, with potentially huge long-term implications and opportunities for all of us to consider, regardless of whether you're directly involved in the construction industry or not. We definitely encourage you to explore these concepts further and think about how these BIM principles, this focus on information and collaboration, might be relevant to your own fields or areas of interest.